Hi, I'm Rajesh Khanna, and I'm going to talk about Parallel Wireless's 5G solution. 5G is going to be not just about connectivity, but about providing experiences. 5G is going to open up several new revenue opportunities for mobile network operators. Parallel Wireless's Open RAN solution offers a solution that can help operators address their current challenges and become more agile, innovative, and mitigate risk with our future-proof solution. Parallel Wireless's Open RAN and cloud-native solution are key to increasing profitability for the operators. Our Open RAN solution provides investment protection with our NEG solution that is completely software-driven. Parallel Wireless provides a programmable, intelligent solution with self-configuring, self-healing, and low latency. Lastly, it offers elasticity with its web-scale cloud-native solution combined with end-to-end network slicing support. Like I mentioned previously, 5G will enable many new use cases and revenue opportunities for operators. The three facets for 5G are enhanced mobile broadband, also known as EMBB, which is a natural evolution of the existing 4G networks that will provide faster data rates and therefore a much better user experience than current mobile broadband services. However, it will go beyond merely faster downloads to provide an increasingly seamless user experience that will eclipse the quality of service we currently enjoy from fixed broadband technologies. Examples include 8K video streaming, immersive, including virtual reality and augmented reality gaming, video analytics, telemedicine, and fixed wireless access. The second facet of 5G is ultra reliability and low latency communication, also known as URLLC. This is a new service category in 5G to accommodate emerging services and applications having very stringent latency and reliability requirements. Examples include smart grids, intelligent transportation systems, and remote surgery. Finally, the last facet of 5G is massive machine type communication, also known as MMTC. This caters to scalable connectivity for a huge number of devices and latency agnostic applications. And all of this should be optimized for small packets, sporadic transmissions, and uplink-centric activity. Example includes energy meters and connected home appliances. 5G will bring about new spectrum such as millimeter wave and new technologies such as massive MIMO and beamforming to satisfy requirements. 3GPP is looking at frequencies from 410 MHz all the way up to 52.6 GHz. These frequencies are divided into two parts. Frequency range 1, going from 410 MHz to 7.125 GHz, referred to as non-millimeter wave 5G, and frequency range 2, going from 24.25 GHz all the way up to 52.6 GHz, referred to as millimeter wave 5G. The 5G use cases of enhanced mobile broadband, ultra reliability and low latency communication, and massive machine type communication all use one or more of these layers depicted in the diagram to provide services. Very high throughput layers in the range of 24.25 GHz and 52.6 GHz will cater to the EMBBB and URLLC use cases. Parallel Wireless has an existing ecosystem of hardware partners that bring their expertise in both massive MIMO and beamforming technologies. The capacity layer, ranging from 1 GHz to 7.125 GHz, will provide the medium for EMBB, URLLC, and MMTC use cases. Parallel Wireless has 2x2 and 4x4 MIMO options available today in 4G, which can be software upgradable to support 5G new radios. The coverage layer sitting in the sub 1 GHz range will provide services for URLLC and MMTC use cases. Parallel Wireless already supports many bands in this range for 2G, 3G, and 4G services, all of which can be reformed to provide 5G services with a software upgrade. The Parallel Wireless solution is completely software defined and based on Open RAN standards. This future proof and in turn offer investment protection to the mobile network operator. Traffic is growing at a much higher rate as compared against revenue growth. IoT connections are increasing exponentially. Operators are not able to cater to premium ARPU use cases like latency sensitive applications due to network infrastructure or technology not being equipped for it. Coverage issues, high capex, opex due to traditional old infrastructure and technology, reliability issues, monolithic purpose-built systems are leading to slower agility in launching newer services. High complexity and maintainability, all of this is taking a significant toll on operators. Thus, operators are looking for ways and means to address all of these challenges and become more agile and competitive, which will enable them to be both innovative and risk-taking while offering best-in-class services to their subscribers. This slide shows a projection for subscriber growth, capex, and technology mix from 2018 to 2025. It is expected that by the year 2025, 5G is going to be almost 15% of the services offered, which is significant compared to recent years. At the same time, there are challenges to offering this coverage, and these challenges are holding operators back from providing seamless and enhanced services in certain areas and thus holding them back from increasing their revenues. The world will be increasingly more connected from now through 2025, with subscriber growth projected to be 9.2 billion by 2025, 1.38 billion of which are expected to be 5G users. This tells us that 5G is a reality both for mobile network operators and end users. It's important to point out here that 2G, 3G, and 4G aren't going anywhere as the world becomes more connected through expanding coverage to previously unconnected areas. As you can see here, smartphone adoption is projected to increase significantly by 2025, and more end users will be using data. As such, 4G will continue to be important while 5G gains traction as more people will embrace the ever-evolving mobile technology. Legacy RANs have been based on proprietary hardware and rely on long and costly life cycles in development, deployment, and operation. This created vendor lock-in and the inability to keep pace with technology and demographic changes. Open RAN is a new movement to open up interfaces to reduce costs. With each generation of radio interface changes, these radios are typically replaced with newer versions at a significant investment and inconvenience to the mobile operators, which in turn perpetuate the vendor lock-in. Open RAN is not just about the DU-CU separation, which only helps with capex savings. Deploying, maintaining, and optimizing network requires a lot of manual labor and results in high cost. This can be addressed by the automation and DevOps approach inherent in Open RAN solutions. There are a lot of legacy networks deployed, so Open RAN should address 2G, 3G, and 4G as well. If Open RAN does not address all technologies for mobile network operators, they are left to maintain two separate networks, legacy and new Open RAN networks. This will be costly and not serve the full purpose of the Open RAN movement. Parallel Wireless's innovative Open RAN solution is truly open, designed to address the requirements of 2G, 3G, and 4G networks with design and programming capabilities that enable software upgrades to 5G. Parallel Wireless's Open RAN solutions, unique low cost, low footprint, and cloud native multi technology solution can help to deliver coverage to low density areas by making deployments easy and affordable to install, maintain, and to upgrade to any future technology, including 5G, on the same hardware without performing site visits. It minimizes the capex and opex in these low density areas where there is high uncertainty on return of the investment for the mobile network operator. It also delivers superior sustainability. As mobile network operators deploy urban networks, easy to install, low cost, and high performing cloud native Open RAN solutions with support for macro or small cell deployments for densification is needed. To deliver superior end user quality of service for consumers and industries with our Open RAN solution, making high density networks easy to deploy and maintain by self configuring and self optimizing them in real time will be needed. One of the fundamental 5G concepts is the ability to provide network slices for different services, application, or use cases. Network slicing offers the potential to reach new customer segments and generate a substantial amount of additional revenue. Parallel wireless solution offers end-to-end slicing starting from RAN going up to the core. This is needed in order to provide the differentiated user experiences and reserve dedicated resources for a particular customer in order to provide guaranteed quality of service and service level agreements. In order to address challenges and increase profitability, operators need capability to become more agile, innovative, and flexible. Parallel Wireless's solution offers operators a set of features that can help them equip themselves with these needed capabilities. Parallel Wireless's solution is a cloud-native, all-G, software-defined, future-proofed, scalable, interoperable, standard-based, and offers differentiated user experience. Our solution provides agility, flexibility, and the lowest total cost of ownership. Parallel Wireless provides cloud-native functions residing on COTS hardware sitting at the cell site, enabling the ease of deployment and scalability for the instantiation of services for 2G, 3G, 4G, or even 5G. Parallel Wireless provides cloud-native functions residing on virtual infrastructure at the edge in the operator's central cloud or data center for its non-real-time RAN intelligent controller functions, including security gateway and aggregator services such as virtual eNodeB, virtual RNC, and virtual BTS. Parallel Wireless provides cloud-native functions residing on virtual infrastructure in the operator's central cloud or data center for its non-real-time RAN intelligent controller functions, including automatic autonomous configuration systems, its element management systems, its AI ML-based self-optimizing systems residing on top of a data lake providing real-time feedback. Parallel Wireless's virtual baseband unit is a cell site COTS hardware component that leverages cloud-native functions at the cell site. Parallel Wireless supports different types of Open RAN splits, allowing mobile operators to pick and choose different splits based on the same hardware and network components by using different software implementations. Mobile network operators require a unified Open RAN solution that supports both their 2G, 3G, 4G, and 5G networks, but to also address the full spectrum of use cases from ultra rural all the way through the most challenging and complex hyperdense deployments. This approach dramatically reduces the total cost of ownership for operators. Parallel Wireless's edge-centric architecture also enables offload at the edge, catering to low latency applications. Parallel Wireless enables the operator to automate the management and operation of its infrastructure, reducing administrative overhead and facilitating application lifecycle management, thereby reducing time and freeing up people bandwidth to focus on new value creation. Parallel Wireless also provides zero-touch provisioning to facilitate the enablement of services on demand for the operator. Parallel Wireless also enables a CI/CD pipeline, which not only automates the enablement of software upgrades, but also the automation of testing these software upgrades. Finally, Parallel Wireless leverages its SON functionality using artificial intelligence and machine learning in a continuous analytical loop on top of the near real-time RAN access controller to optimize the network based on real and continuous feedback.